Okay, so green 8. So the problem asks to confirm that the area of the unit disk is equal to pi. Okay, well, use Green's theorem. Well, what the problem means is use this particular special case of Green's theorem, the one that computes area, right? And in particular, if you have a curve like that, that's the boundary of some region D. Then the integral over that boundary of x dy is equal to the area of D. Right? Because of Green's theorem. Because if you look at this, what's the vector field involved in this vector line integral? Well, it's a vector field such that the Green operator gives you 1. And so the double integral turns into area. Is that cool as to why this is true?
Yeah.
Okay. So if you want to compute area, compute this line integral. So we need to parameterize this curve. And, well, it's the unit circle, so I'm going to parameterize by, well, let me write it like this. Let me write x equals cosine t and y equals sine t. So, of course, x prime is negative sine t and y prime is cosine t. And integral of x dy then becomes, this is just a matter of kind of writing down what it is. X is cosine t. Oh, by the way, t goes from 0 to 2 pi. So x. dy is y prime dt. If you look back in the section on coordinate line integrals, right, dy is y prime dt. And so that gives us times cosine t dt. So we end up with integral from 0 to 2 pi. Cosine squared t dt, and this is just a calculation, Math 32 calculation at this point. Is that okay, or did you have trouble with this calculation?
I had trouble with that.
Okay, yeah, let's do it. Yeah.
Okay, go ahead.
Yeah, no worries. So this, by the way, so Math 32 is one of these things that's unavoidably going to be a part of, I'm not going to say all, but many of the calculations that we do in this class. So, this is a good one to know, and there's a whole section in Math 32 called trig integrals for how to deal with stuff like this. And in this particular case, the trick is to use a half-angle formula. And the half-angle formula in question is cosine squared of t equals 1 plus cosine 2t all over 2. And note that something of a squared ends up not being squared. So I can rewrite my integral as integral from 0 to 2 pi of 1/2 plus 1/2 cosine 2t. And this I'll bet you can probably handle. Right? So the point is this is that has an easy antiderivative. That has an easy antiderivative. And it's just fundamental theorem of calculus. Plug in 0 to 2 pi. And let me just say ... equals pi. Cool.
Thanks.
Yeah, no worries. Is everybody happy with this? All righty.